Hello everyone, and this is Dr. Lakshmi Tara, Assistant Professor, Department of Electronics and Communication Engineering from SRM Institute of Science and Technology, Kattangaluttur. Here we are going to see about fiber optics and optoelectronics. First, we need to explore about the elements of optical fiber in the communication systems. So, first the required informations are from message sources. From the message sources, how it has been propagated. We know that while communicating, we should have the transmitter and the receiver. So the transmitter gets the information from the message source which has been propagated through the channel, and it has been received by the receiver, which is given to the destination side. Okay, so this is the overall block diagram. Okay, when come to the optical communication, fiber optical communication block diagram, so our received inputs, our received either optical audio signals or any kind of video signals that has been in the form of electrical signals. So these electrical signals has been converted into the optical signals. Here we are going to speak about the fiber optic communication. So optic means light. So we are propagating all the informations in the terms of light. Why we are going for the light means which has the high speed when compared to the other media. So we are converting the electrical signal to the optical signal. So how we are converting the electrical signal to the optical signal to the driver circuits, so which is in the transmitter side. So in the transmitter side, first it converts the electrical input signal to the light source. Okay, this light source has been propagated over the optical fiber, which is the transmission channel as given here. See here, the electrical signal is given in the dark lines, whereas the light sources has been given in the form of dashed lines, cross lines. Okay, so in order to transmit the signals, propagate the signals, we should require the connectors and the optical splices. Okay, the light has been given to the regenerator, so where it has been received and it has been converted into the electronics, and it has been optically transmitted. Okay, optical transmitted and is given to the receiver side. So before reaching the receiver side, because of the some kind of disturbances, there will be a variation in the signal strength. In order to increase the signal strength, we are using the optical amplifier that amplifies the signal level. So that optical signal has been photo detected. That means it detects the light and converts into the electrical signals. So it has been detected using the photo detector. Photo means optical detector. Okay, that signal again gets amplified and given to the signal restorer, which is given as the electrical signal out. Okay. So here we are going to briefly discuss about the transmitters. What are the blocks we have seen in the block diagram? Here we are going to see in the expanded manner. So optical transmitters. So we know that it converts the electrical signal to the optical format. So which is given as electrical to optical formats. So what are the transmitter we are generally using is light emitting diode LED. We know that we are in wherever we are seeing about the LEDs and the laser diodes. So these two are the transmitters. Mostly we are preferring the LED because of the cheaper cost. And it has been available whenever we require, we can get the LEDs, and it has been used in the multimode fiber. This MMF stands for the multimode fiber. Okay, and for the short range applications, we are using the light emitting diode. Okay, light emitting diode can be available in both the forms. One is surface emitting diode and another one is the edge emitting diode. The next one is the laser. So laser always it is expensive because of its higher performance. So it is more power, so it is used in the single mode fiber. Okay, it has been available in the form of distributed feedback laser and the Fabry Perret lasers. So we know that distributed feedback lasers are the high performance single mode lasers, and the Fabry Perret lasers are the low performance multimode lasers. The next important thing is the optical receiver. So whatever we are transmitted, that should be received by the receiver end. So what we have transmitted, we have transmitted the optical signal. So what should be the source of the transmitter? The electrical signal. So whatever the message should be in the source, that should be received by the receiver end. If there is the electrical signal, then we can give the destination side the electrical signal. So what the optical receiver do, that converts the optical signal into the electrical format. So what are the available optical receivers are pin photodiode, avalanche photodiode and the phototransistor. We know the expansions of the pin photodiode, that is positive, intrinsic, negative photodiode. It shows the low performance when compared to the avalanche photodiode because of the multiplication factors. It shows the higher performance, that is avalanche photodiode shows the higher performance when compared to the pin photodiode, where the phototransistor shows high performance in both internal and external gains. It shows the high internal and the external gains. Other things are the amplifiers, optical amplifiers, that amplifies the light in the fibers. The repeaters also do the same as like the amplifier. It amplifies the signal wherever it weaks, so it receives the weaker signal and it amplifies the signals. Okay, once we have completed the transmitter and the receiver. So what the transmitter does, it receives the electrical signal from the message source and it converts into the optical signal. So what the receiver does, it receives the optical signal and converts into the electrical format. What the amplifier does, the amplifiers increases the signal strength. Amplifiers and the receivers does the same. So in between the transmitter and the receiver, so how the light has been propagated, in what media it has been propagated. So there should be the channel, there should be the media should be there to propagate the information or any kind of signals from transmitter to the receiver. Here the fiber act as the light carrier. Okay, so in this diagram we can see the core. The core is the very important thing that propagates the light. The cladding and it is surrounded by the cladding. The core cladding, based on the core cladding we can say the effectiveness of the light propagation, how effectively it has been propagated, how efficiently it has been propagated. It has been entirely based on the core and the cladding. The remaining things, coating, tight buffers, tent members and cable jackets, these are external added strength materials for protective members. These four are the protective members that gives the protection to the core and the cladding. Okay, here they have mentioned the silica. The silica polymethyl methacrylate, PMMA stands for the polymethyl methacrylate. These two materials and glasses are mostly useful for the manufacturing of the fibers. Okay, then they have mentioned the step index fiber and the graded index fiber. The name itself, index, has been mentioned. So it is entirely based on the refractive index difference between the core and the cladding. Okay, if there is mentioned as index fiber, then it is entirely based on the refractive index difference between the core and the cladding. The step index fiber means the refractive index difference between the core and the cladding is in the form of step. Okay, that is abrupt transition should be there between the step and the core and the cladding refractive index. Wherein the graded refractive index, the name itself graded, the word mentioned here as a gradual change. So there should be what, instead of the step transition, that is abrupt transition, there should be what, a gradual transition from the between the core and the cladding. The next one is the single mode fiber and the multi-mode fiber. There they have mentioned based on the index difference, the refractive index difference. Here it is entirely based on the modes. How many modes that has been propagated over the fiber. The name itself single mode fiber, only one mode has been propagated in the entire fiber. For example, if you go for the laser, we can use the single mode fiber only for the high performance. Okay, for the multi-mode fibers, the name is of multi-mode, so multiple modes has been propagated in the single fiber. Okay, so we can effectively use the fiber. So we can in a single fiber, if you are transmitting the more number of fibers, okay, it is highly efficient. So multiple modes has been propagated when compared to the single mode fiber, where only one mode has been propagated. Okay, so which is cheaper? Multi-mode fiber is cheaper. Okay, so so mostly we are using the multi mode fibers. If there is more number of students are there in the classes, then definitely there should be noises there. Similarly, it offers higher dispersion. Okay, but in the single mode fiber, for consider only one students in the class, then how should be the rate of understanding? There should be what? Higher much rate of understanding, so it offers the higher bit rate. So more number of bit rate should be transmitted over the single mode fibers. Okay,